Okay, so let's go through the Emcf number 3. Okay, question 1. An equation for the plane that passes through the point, so number 1, P, which is minus 4, 5, 2, and contains the line, so remember this is a line, x plus 3 over minus 1 equals y minus 2 over 3, and z plus 2 over 2. Okay, so remember that this is a line in symmetric form. Okay, so I want the equation of a plane, so that means I need a point on the plane. I have that. And I need the normal vector. Okay, so to get the normal vector, what I'm going to do is I'm going to get two vectors on the plane. So there's two ways to do this. I know that this line lies in the plane. So that means that the direction vector is also going to lie in the plane. So actually, straight from the symmetric form, I can get a point on the plane. I'm going to call it Q, which is going to be minus 3, 2, minus 2. Right? I know this is on the plane. I also know that the direction vector, which is minus 1, 3, 2, this is also a vector in the plane. So this is a point on the plane. This is a vector on the plane. I need one more vector on the plane. And the way I do that is by doing the vector PQ. Right, so what is this? This is minus 3 minus minus 4, that's 1. 2 minus 5, that's minus 3. Minus 2 minus 2, that's minus 4. So this is a vector in the plane, and this is also a vector in the plane. So now that I have two vectors in the plane, I can do the cross product of the two. And this is going to give me a vector that is orthogonal to both of these vectors. It's going to also be orthogonal to everything else in the plane that contains these two vectors. So let's get computing. I, j, k, plus, minus, plus, and I have 1, minus 3, minus 4, minus 1, 3, 2. Okay, so this is going to be something I hat. I'll fill that in later. Okay, so I hat, we cross that out. We get minus 6 minus 3 times 4. 3 times negative 4, which is minus 12. Okay, so now we minus j hat. So we cross the middle out. We have 2 minus positive 4 plus, across the last one out, we have 3 minus 3. So that's 0. So in component form, this is going to be minus 6 plus 12, that's 6, minus minus 2, so that's positive 2, and that's 0. Okay, so this is our direction vector. I'm sorry. No, this is our normal vector. This is normal to the plane, right? It's orthogonal to the direction vector that's in the plane, and it's orthogonal to PQ. So, I have the equation n, so this is going to be my normal vector, dot x, y, z equals n dot some point in the plane. Okay, so n dot xyz, so I'm going to have 6x plus 2y equals something. I could pick any point here, and it really doesn't matter, but if I look at the answer choices, there's only one answer choice that actually fits with the 6x plus 2y, which was answer choice B. And so I know Q was in the plane, and I also know that P was in the plane. So I could have picked either of those to fill in this right-hand side. Okay. Number 2. The angle between the planes minus 2x plus y plus 2z equals 7, and the plane 3x plus 4z equals negative 1. So here, the angle between two planes is the angle between the normals. So this is going to be n1, which is minus 2, 1, 2, and n2, which is 3, 0, 4. Okay, so the cosine between the two angles we just said was the cosine between the normals, which is n1 dot n2 over the norm of n1, norm of n2. Okay, so n1 dot n2, that's going to be minus 6 plus 8 over, that's going to be 3, and that's going to be 5. Right, 4 plus 1 plus 4, that's 9, square root, we get 3. 9 plus 16 is 25, square root, we get 5. So this is going to be 2 over 15, which was answer choice A. Number 3. The distance from the point A, which is 4, 1, minus 3, to the plane P, which is 2x minus 2y plus z equals minus 6. So we want to find the distance. So here, let me write down the normal. This is going to be 2 minus 2, 1. Okay, so we have this formula. If I write this with this number right here on the other side, I need to do that. So this is going to be A, B, C, D. Okay, so I use this formula. AX plus BY plus CZ plus D over square root A squared plus B squared plus C squared. Right, so the XYZ, those are the points that we're plugging in. A, B, C, right, those are the coordinates of the normal. D is this value right here. And this right here, you should recognize that as the norm of the normal. Okay, so I start plugging numbers in. So I have 4 times, that's 8, 1 times minus 2, minus 3, plus 6 over the norm of the normal, which I know is going to be 3. So that's 6 plus 6 is 12, minus that's 9, or 3. Answer is 3. So the answer choice was D. And just to recap, if you recall, so we have a plane, and we have some point way up here. If we have another point, and we make this vector, so this was A, we pick some other point P. And we have the normal sticking straight up out of the plane. Okay, this distance, so this is the normal, this distance right here is just the component of from P to A, the vector from P to A, PA. It's just the component of this in the direction of n, right? It's the projection of PA onto n, and the length of that, right? It's the component of this. And that's all this formula is. Okay. Number 4. Given A and the plane in the previous question, so that's A, which is 4, 1, 3, 4, 1, negative 3, and 2x minus 2y plus z equals 6. Let L be the line that goes through A perpendicular to P. Okay, so we'll probably have to find the line. And it says the point B at which the line L intersects P is what? Okay, hang on. What is it asking? It says given point A and the plane P in question 3, let L be the line through A perpendicular to P. Oh, I see. Okay, so again, we have this plane, we have some point up here, and then there's this line that goes straight through this, straight through here. Okay, and this is orthogonal to the plane. Okay, I don't know what this point is. We'll figure it out in a second. But I want to figure out the equation of this line, and I need to figure out where does it intersect right here. Okay, so let's go ahead and first let's find the equation of the line. So we know the direction vector of this line. It's just the normal to the plane, right? Because the line has to be perpendicular to the plane. So the normal is the same as the direction vector, which is 2 minus 1 minus 2, 1. Okay, so that means that the equation of the line is going to be 4, 1 minus 3 plus t times the direction vector, right? The direction vector, which we know is the same as the normal. Okay, so now I want to find where does this intersect with the plane. So let me go ahead and do this. I'm going to write this in parametric form. So I have x equals 2t plus 4, y equals minus 2t plus 1, z equals t minus 3. Right, and I just distribute those out. That's how I got these. Okay, so now I know what x is in terms of t, what y is in terms of t, and what z is in terms of t. So I'm going to take these values here, plug them into the plane, and figure out what is the value of t that makes this true. So basically what this is saying is, as t changes, I'm going up and down the plane, right? So I can write it that way. And I want to figure out at what value of t am I actually on the points that satisfy the plane. So I have 2 times 2t plus 4 minus 2 times minus 2t plus 1 plus t minus 3 equals 6. So I'm going to solve for t. So I have 4t plus 8 minus plus 4t minus 2 plus t minus 3 equals 6. That's 8t, 9t. This is a 6. So here I have 6 and 6 on both sides, so those cancel. I have 3, so that goes over. So that tells me that t is 1/3. Hopefully this works out. Okay, so at t is 1/3, what are my x, y, and z points? So x is going to be 2 times 1/3 plus 4. So that's the same as 2 plus 12 over 3. Y is going to be minus 2 over 3 plus 1, which would be, so that's 4 minus 2, that's 2 over 3. And z would be 1/3 minus 3, that's minus 8 over 3. So altogether I get the point 14 over 3, 2 over 3, minus 8 over 3. Okay, that wasn't one of the answer choices. So let me have a look at what the answer was supposed to be real quick. Okay, answer choices haven't been uploaded yet. So let me double check this real quick, see if I can find a mistake. So 413, let's double check I copied everything down right. 41 negative 3, that's correct. 2x minus 2y plus z equals 6. Ah, equals negative 6. Okay, so that doesn't affect any of the line or these parametric equations, but it does affect plugging it back in. This was negative 6. Okay, so let me erase all this. Come on, erase. Okay, so now we have 4t plus 8 plus 4t minus 2 plus t minus 3 equals negative 6. Alright, so I still have 9t, but now I have plus 3 equals minus 6. There we go. So now we have that t equals negative 1. So if I take that and I plug it in, I have x equals minus 2 plus 4, which is 2. Y equals 2 plus 1. Z equals minus 1 minus 3, which is minus 4. So the intersection point is going to be 2, 3, minus 4. Which again is not one of the choices. Do one last check. So I have 2 minus 2 plus z equals minus 6. Okay. Let L be the line that passes through A and is perpendicular to P. So it's perpendicular if it's in the direction of the normal. Okay. So 4, 1 minus 3, 2 minus 1, 2, 1. Okay. So I have 4 plus 2t. I have 1 minus 2t, minus 3 plus t. Okay, so I took those and I found the t that satisfies these and satisfies the equation. Right, 2t plus 4 times 2 minus 2 times minus 2t plus 1 plus 1 times t minus 3 equals minus 6. Okay, that's good. And then I distribute 4 times, or 2 times 2t, 8, 4, minus 2, t minus 3. Okay, I'm going to stick with that answer. And I'm going to say the answer is not up there. Okay. So it says the planes, number 5, the planes 2x minus 4y minus 6z equals 1 and x minus 2y minus 3z equals 2 are what? A, parallel, B, coincident, C, intersect in a straight line, D, skew, or E, none of the above. Okay, well, it's going to have to be A, B, or C because it's always going to be one of those three. Okay, if it's skew, that's referring to lines. These aren't lines, these are planes. Planes are always going to be, it's kind of like lines in 2D, right? They're either parallel, coincident, or they intersect. But they always intersect along a line, not at a point. Okay, so they are, let's see, let's draw the normals, or let's write the normals. N1 is 2 minus 4 minus 6, and here we have 1 minus 2 minus 3. Okay, so notice real quick, we have that n1 is 2 times n2, right? So here, n1 is a multiple of n2, meaning that n1 and n2 point in the same direction, are parallel. Okay, so they're parallel, but now we need to check, are they actually just the same? Right, so that would mean that I could divide this by 2 and end up with the same number on the right hand side. So if I divided this by 2 so that I have the same normal, right, so I divide by 2, so I would have x minus 2y minus 3z, right, so that part's the same. But on this side I have 1/2, which is not the same as 2, so they are parallel but not coincident. They're not actually the same plane. So this was answer choice A. Okay. Append. Okay, the direction vector for the line of intersection of the planes. Okay, so we have number 6, x minus y equals minus 4, 3y minus 4z equals 6. So the normal for the first one is going to be 1, minus 1, 0, and 2 is going to be 0, 3, minus 4. Okay, so what is it asking? It's asking for the direction vector of the line of intersection of the two planes. So if I have plane 1 like this, and I have plane 2 like this, okay, and I have the normal sticking out here and the normal sticking out here. So this normal, n1, it's orthogonal to every vector in this plane, specifically this vector right here, right? That vector is in the plane. So it's going to be orthogonal, our direction vector is going to be orthogonal to, or orthogonal to n1. Also though, n2 is also orthogonal to everything in the plane. Specifically, n2 is also orthogonal to D, right? So we know that n2 is also orthogonal to D. So we know that the direction vector is going to be orthogonal to n1 and n2. So how do I get a direction vector that's orthogonal to the two vectors? Well, I just do n1 cross n2. And let's compute. So this is going to be 1, minus 1, 0, and 0, 3, minus 4. Okay, so this is going to be, cross out the I, we have 4 minus 0, I hat. And then we have minus, cross out this, we have minus 4 again. And then for the k component, we have 3 minus 0. So this is 4, 4, 3. Okay, and this is the, let's see. So this is the direction vector for this. Okay, I don't see one of the answer choices. Okay, let's double check. I have x minus y equals negative 4, 3y minus 4z equals 6. Okay, so this is 1, negative 1, 0, 0, 3, minus 4. Okay, so if I cross out I have minus 1 times minus 4, that's 4, minus 0. Okay, here I have minus 4. Okay, here I have 3, minus 0. Okay, so this is my direction vector. Now, I could have a direction vector that's a multiple of this, right? So this is my direction vector. But it's also totally possible that, like, let's see, 8, 8, 6, right? A multiple of this. This is also, it also points in the same direction, so it would work just as well as the one we found. Okay, so any multiple of that would be fine. However, none of the answer choices seem to be a multiple of that. I'll check one more time that I did my determinant correctly. So cross out I, we have 4 minus 0. Okay, we cross out j, we have 1 times minus 4, which is minus 4, minus 0. Okay, and cross out this, we have 3. Yeah, okay. So that's my, well, not that one. This is my normal vector, or sorry, this is my direction vector, and I'm going to answer E. It's not, answer choice isn't up there. Okay, finally, last one is fairly simple. We have f of t equals sine of t over 2t I hat plus ln of 1 plus t j hat plus t squared plus 2 over e to the 2t k hat, and we want to evaluate limit as t goes to 0 of f of t. Okay, so if we can't just plug in, well, if we do the limit as t goes to 0 of the first component, that's going to be, so sine t over t goes to 1, so that's going to be 1/2. At t equals 0, this is ln of 1, which is 0. And if we plug in 0, we have 2 over 1, which is 2. One half I plus 2k. 1/2 I plus 2k. This was answer choice C. All right. So 2 questions that I didn't see the answer for up there. There's a mistake. Be sure to let me know or point it out in the comments. And that's all.